Good morning, good students. Hope you had a good weekend and must have completed both the assignments, right? In our previous class, we had learnt and derived Newton's inverse square law, acceleration due to gravity, small g, and value of g, which is 9.8 meter per second square. We also learnt variation in value of g along surface of earth, change with height as well as with depth, and the difference between mass and weight. Today we will learn about free fall, gravitational potential energy and escape velocity. Free fall. To understand it better, let's do a small activity. Take a small eraser, hold it in your hand. Which forces are acting on the eraser? Now, release the eraser. What do you observe? What are the forces acting on the eraser after you release it? Well, we know that the force of gravity due to the earth acts on each and every object. When we were holding the eraser in our hand, the eraser were experiencing this force, but it was balanced by a force that we were applying on it in the opposite direction. As a result, the eraser remained at rest. Once we release the eraser from our hands, the only force that acts on it is the gravitational force of the earth, and the eraser falls down under its influence. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Thus, the released eraser is in a free fall. In a free fall, the initial velocity of the object is 0 and goes on increasing due to the acceleration due to gravity of the earth. During free fall, the frictional force due to air opposes the motion of the object, and a buoyant force also acts on the object. This we had seen in the last video when the paper and stone were released together. The paper took time due to the opposing force of air to reach the ground. Thus, true free fall is possible only in vacuum. So, free fall, motion of objects moving freely under the force of gravity only. For a freely falling object, the velocity on reaching the earth and the time taken for it can be calculated by using Newton's equations of motion studied in standard 9th. V is equal to U plus AT, the first equation. S is equal to UT plus half AT square, second equation. V square is equal to U square plus 2AS, third equation. But remember, for a freely falling body, initial velocity is 0. So, U is equal to 0 and A is equal to G. Hence, the above equations will look like this. V is equal to U plus AT becomes V is equal to GT. S is equal to ut plus half at square becomes S is equal to half gt square. V square is equal to u square plus 2as becomes v square is equal to 2gs. So students, for calculating the motion of an object thrown upwards, what would you take the acceleration? Correct. It would be negative. That is, in a direction opposite to the velocity and is taken to be minus g. So, the magnitude of g is same, but the velocity of the object decreases because of this negative acceleration. So, for a ball thrown upwards, the acceleration due to gravity will be minus g, which is equal to minus 9.8 meter per second square. Followed, students? Now, let's understand gravitational potential energy by watching the following video.